Oh, daar gaat het bij liggen.
So, well, thank you very much for being with us on Virtual Azure Community Day. Next up is Stacy Cashmore. Welcome, Stacy, in our studio.
Hi, fantastic to be here. It's awesome.
Yeah, do you like it?
Yeah.
It's a really industrial vibe. We loved it as well. It's actually quite nice to be here all day because, well, it's a quite long event, 24 hours, and we don't notice if it's day or night.
So we just pass out on the couch.
Yeah,
and,
at some point somebody walked in with
with
burgers, and I was like, oh, that's like breakfast or like, I don't know. I assumed it was dinner, by the way. Okay, so Stacy, let me do a quick introduction, but I think you can do it yourself maybe better, but you've been writing like software like forever. And like the 90s.
I started developing software in the mid-1990s. It's during my sandwich year at university, so that'd be about 95, 96 I started.
Yeah, now you're mostly, also trying to spread knowledge and make, let other people learn other people how they can be, more, they can write their software, how they can do it better.
Yeah, what I really like to do is to really help developers and teams experiment with stuff and try new things and fail and learn from the failing and then actually go back and do something really awesome.
Yeah, it's more about the process now, improving the process, and less about the tech stuff.
Yeah.
Right. Cool. Nice.
Awesome. And well, you can, I think, better explain what you're going to talk about than anyone else in this this building. So can you elaborate a little bit on what your next session will be about?
Yeah, the session is just about, it's based on an experiment that I had at a previous employer where we really wanted to play with Azure, but we didn't really have the go-ahead, so we had to do some experiments to get some answers to things. Mm-hmm. And it's just a little bit that I learned from part of the week of experiments that we had that was just kind of wow, you can actually do stuff really quite easily and get stuff up and running, get data in, and really start the learning process from I don't even deploy to my own servers. I put it into TFS and somebody else deploys it later, to actually setting up something where you have full control over what you're doing. And it's only something small and simple, but the first time you do it, it gives you that real, yes, of actually getting something up and running.
Does that ever wear off, I wonder?
I hope not.
No. Exactly. Sometimes you get the challenges, but it's quite rewarding when it works. Well, awesome. So, I will invite you to the stage.
Thank you very much.
To enjoy your session.
Yeah.
So, make sure you don't trip.
I'll do my best not to. There's lots of cables and I'm in heels, but we'll cope. So, good evening everybody. Really, thank you for spending your time with me this evening. Let me just get this started. There we go. So, I'm going to be talking about Azure Functions and Azure Storage. And as I was saying, this came about basically because as developers, we really want to work on the latest things. We want to be able to keep our skills up to date with the new technologies that are coming along. And we want to use the best fitting technologies to solve problems in the best possible way. And over the last decade or so, cloud solutions have come to fit this more and more. And yet, actually being able to use these technologies, it's something that takes far longer than we'd like sometimes. Some larger, some older companies, they can be hesitant about the move to the cloud. And whether that's through fear, lack of internal knowledge, or whatever other reason, lots of developers still find themselves working on legacy in-house systems. And when you do that, your code does get deployed. You see your things in production, but far too occasionally, not as often as you'd like, and with a lot more effort than you'd like on top of this. You have no control over how things get deployed. You give it to somebody and it ends up in production. And should you ever need new hardware, sometimes it can take months before that is available to you. But you've been reading about Azure. You've been itching to give it a try. Maybe this is a thing that you can use to try and start working in that cloud-native environment. But there's always a but. Trying to get that go-ahead in the companies can be really difficult. You find yourselves being asked questions that right now you can't specifically answer maybe. Wouldn't it be cool to just quickly build something in order to get some of those answers and to prove what you can do and how long it takes? And at a previous employer, this is exactly the position that we were in. As a development team, we really wanted to move to Azure. The feature that we were building was screaming out for it. It would have made our life so much easier. But our ops team and our budgeting team, no, absolutely not. Not until you can give us some answers at least. Now, this isn't totally unfair, of course. You should be able to give answers. But what answers are acceptable in this situation? Because there's reams of research on this, not least of which the State of DevOps reports, which really supports the move to the cloud to help your team. But we're dealing with people. And people need to know about these things when they're unknown to them for themselves. They need to feel it themselves. They need to see the results with their own eyes. And so we had a hack week, a chance to show what we could build in a short time frame, with the whole team working together, and check things like costs at the end of that week. And when I say whole team, I really mean the whole team. We had every development team working on this. The ops team joined us so that they could help us. We even had our product owners to make sure what we were building was something that could be usable in the real world to help our customers, and not just some abstract tutorial thing that wasn't actually real world ready at the end of it. Now, I'm going to use in this talk part of the experiment that I did with my team during this week. And it's just a simple application, uses a few different resources inside of Azure, and it replicated something that we could build upon to help customers in the future. Now, this application, it's just a simple way to get data from a static Angular site and into Azure storage. Now, throughout this demo, I'm going to be doing a few deploys to my Azure environment. I'm going to be using Azure DevOps to do this, but I'm not really going to go into how I'm using Azure DevOps. I'm just going to give you a brief look at the pipelines I'm using, and then we're going to continue. I'm also cheating a little bit. I'm using a pre-made Azure environment. I'm doing this because making resources in Azure can sometimes take a little bit of time, and I think it's better for you to see something working than me staring at the screen just hoping that it gets created sometime soon. But what I am going to do, any resources I use, I will be walking through the steps you need to do to create it in a separate environment. And finally, before we start, this is going to go at a little bit of a pace, I'm afraid. But don't worry, I've got a blog post that you can follow through yourself later if you want to try for yourself, and it'll explain things in more depth and have links to more details. Now, enough talk, let's get to the demo. So what I want to start with is just to show you the Angular application that I'm going to be using here. It's really simple. It's one page. Sorry? Can I zoom it a little bit? Yes. There we go. It's a single page, and basically all we're doing, it's for a book club that people can sign up to. So we just want their name, their email, and the genre that they're interested in. And this fires off a request to our API that we're going to be working with. Now, we're not changing this at all throughout the demo. This stays the same. It's only the API that we're going to be looking at. And then how I'm getting my code into Azure, just to quickly show you what we have, is just a simple 5-step pipeline. If Azure DevOps does its thing. This is just set up for continuous integration, and basically we just do a .NET restore, a .NET build. We do .NET test, because of course I have unit tests in my demo code. And then we do a .NET publish to get what we want to push to Azure, and then publish those artifacts to pick up in our release pipeline. I've got 2 of these pipelines, one for each thing that I'm going to be building. I won't bore you by showing you exactly the same thing a second time. And then in order to actually get my code into Azure, I just have a release pipeline which picks up the build artifact from the first step and very simply throws it at an Azure app service. And then finally, before we get started with the code, this is my API that we're going to be using. It's almost as it comes out of the box. I've just done a little bit of cleanup because I don't like having things like class 1 lying around and test code. The only thing that we've had to do, because I am talking to a static Angular site, is I've just had to change my startup CS just so that I can do cross-origin requests to my Azure location. Other than that, I have a model here so that I can get data from my users. And then I have the controller that's going to pick it up, which right now is totally empty. So the first thing that I want to do is just show you how we can get the data from the user and throw it directly into an Azure table. So for that, I'm just going to need to create a couple of classes. And if my computer does something, I can carry on. So I'm just going to make a folder in my solution to organize my code. We'll call that table access. And then the first class that I'm going to create, this is the one that actually stores my data in the Azure table for me. Let's make a new class. And that one is going to be called Storage Table Access. Now, you don't want to be watching me type because that would be quite boring. So I just have a little bit of code that I'm going to paste in here. And we're going to be using the Microsoft Azure Cosmos table namespace. Now, you can see it's red right now. So we're going to need to add a NuGet package so that we can use this. So let me just add the NuGet package here. And we'll just search for it. No, not that one. Well, just to install the latest. And of course, we're going to accept anything that comes up, because why do we ever read these things? And then when we get back to here, hopefully that red text is going to disappear. What we have right now is quite a simple empty class. It's only got a few things in it. We have a constant for our connection string, which obviously you're not going to have in your production code, but in a demo it's fine. And then we're passing in a table name, and that comes in through the constructor because we want to use this class for each of the tables that we have. We don't want to rewrite this every time. And then how do we actually do our insert? I'm only looking at adding table to the storage for now. We're not going to be reading data out of it. In order to do that, in order to insert data, we need to do 3 steps. We need to get a table from our Azure storage account. Then we need to make an insert operation for the data that we're passing in. And then we need to execute that against our table that we've gotten from Azure. But you can see my get table async, that's red right now, so we're going to need to add just a little bit more code. And this actually gets the table reference from Azure for us to use. The first thing that we need to do is, using our connection string, get a storage account. And then using that storage account, we get a table client. This gives us access to our tables in Azure Storage. And then we need to get a reference to that table. Now, the interesting thing here is you can get references to tables that don't yet exist. It's awesome. It means that you don't have to set up your entire storage account before you start coding. It has a downside of, if you try and access a table that doesn't exist, obviously it's going to crash on you. So we have this next line here, create if not exists async, and I think the name is quite descriptive. It checks if a table exists, and if it doesn't, it creates it for you. And then we return the table to our calling code so that we can use it further. Now, we've still got a little bit of red text here, this sign up entity, and this is going to be our model for the data that we're actually going to throw into the storage account. So let's just add a new class here. If I can find the add function. And again, I'm just going to copy a quick code snippet here so that we can look at it. So here we have our sign-up entity. It's based on a table entity. This is what you need to use in order to store data inside of an Azure Storage account table. And a table entity has two important properties. We have a partition key and we have a row key. And basically that makes sure that your data is unique within the table, and it also organizes how your data is stored within that table. Now, personally, I don't like having partition key and row key spread throughout my code. So I've just wrapped these in properties just with the ignore property on it, just so that I can use something that makes more sense to me in my domain in my actual code. And then lastly, in this class, we need, of course, the data that we want to store, which is just 3 strings for name, email, and genre. Now I'm just going to do a quick build to make sure that I've not broken anything. And that worked. So if we go back to our controller now, we actually need to call this data. So we've got 2 lines of code that we need to add. We'll just make sure that our using statements are correct. The first one is just to call that new class that we've just created, just to get access to the table access. And the second one is to actually perform the insert operation. And we're doing that using the request that we get from the users. But the insert function expects a sign-up entity, and we're getting a book club sign-up request into our controller, so we just need to do a little bit of adaptation. So we've just got one more function to add. And this just basically copies the data over to our sign-up entity so that we can use it. I have cheated a little bit here. In your production code, obviously you're going to make sure that you don't have data collisions, so that I don't need to worry about that. I'm just literally making sure that all of my names are unique by adding the date time now ticks to the end of it. Please don't do this. This is not a good solution. So one more check that it builds. It does. So now I'm going to push this up to Azure, and then we can see what we need to do there. So we've added our table. We're going to commit this and push it. And then we're going to go back to our DevOps. I just want to check the pipeline's building, because it should be. There we go. Now that is the code that we need to do in order to throw some basic data into a table. But what resources do we need to use? Well, the first one that we need is a resource group. And this is how we organize our resources within Azure. So let's just quickly add that one now. We'll click this add button in the corner. And hopefully the portal is going to do something. There we go. And we're just going to call this live demo. And I want this in West Europe because that's where I'm located. Your resource group also contains metadata for the resources that you create inside Azure. They may be compliancy things in your region that you have to store this metadata in a certain place. So when you do this for real, always check what you have to do and where you need to create your resources. We'll just review that and create it. And there we go. Now this has already been created. I know that I said a couple of minutes ago that it takes time to create Azure resources. Until now, resource groups has not been part of that for me. They've been created fairly quickly so we can use it. The rest of the resources take a bit more time. So now we have our live demo, because apparently I can't type, but we need to fill it with actual resources. Now for the code that we've written, we need 2 resources. We need a web app to host the API, and we need a storage account where we can store our data. Let's add the web app first. So just in case you didn't see that, we have an add button at the top. We click on this add button, and we want a web app. Now we're going to check that our subscription and our resource group are correct for this. We need to give our web app a name. So we'll call this live demo. And I spelt it right this time, but I can't use it because it's already in use. As you can possibly see from this text down here, this name is also how we access our web app. So it has to be unique across the whole of Azure. So we're going to need to change this to maybe web app. It's thinking, it's accepted that, so we can use this one. We're going to be deploying code. We're going to be deploying .NET Core 3.1 LTS and on Windows. And again, we want to deploy this into West Europe. Now, as well as having a web app, we also need an app service plan for that web app to run on. If you think of the web app as the IIS for your application, the app service plan, you can think of that as a metal that your IIS is running on. So we're going to create a new one for this, and we're going to call this Live Demo App Service. And then we need to pick the size of the app service plan that we want. So we're going to click on this change size down here. And this opens up our spec picker. And here you can see all of the different sizes of app service plans for the processing needs that you have in your application. Obviously, the more power you have, the more money that you spend. And for this demonstration, we need almost none, so we're going to take the free tier. Now, the free tier has a limitation. You only get 60 minutes of compute time per day. But that compute time doesn't mean that this API is only available for 60 minutes. It's actual processing time inside of that app service plan. For what we're doing, this is perfect and costs nothing. So we'll apply this. We'll review and create. Just do one quick check to make sure that I've not done anything daft. And I think that's all okay. So we'll click create. Azure will now go away and make these resources for us. Generally takes kind of, well, between 2 and 10 minutes, depending on how busy Azure is. Now, we still need to add another resource to our resource group, and that's our storage account. So we're just going to add a new one. Now, the storage account is down here, but if you ever can't find anything, you can always just type into the search bar, and then we get our storage account here, and you can create it. So again, we're going to check our subscription, and we're going to check our resource group, and then we need to give it a name. So again, we'll do live demo because I'm using that for everything. And you can see that for the storage account, we have slightly different requirements. We can't use capital letters. In fact, we can only use lowercase letters and numbers. This can make the names a little bit interesting to read when it gets too long. It means that we can't do camel case, Pascal case, kebab case. We just have to have one big long string, I'm afraid. So let's do that now. Live demo. And we can also see this also has to be unique because this is also how you access your storage account across the web. So we'll just see if we can make that unique, and that worked. We're going to run this one in West Europe too, same as everything else. And the location for a storage account is important for 2 reasons. First one is performance. You want your storage as close to your metal as possible. If you've got co-located processing and storage, it can be milliseconds to get your data. It's really quite quick. If you put your storage on the other side of the world, that can be tenths of a second, and your user experience is going to be really degraded. You don't want that. The second thing you've got to consider, the same as for the metadata for your resource groups, is local compliance laws. Here in the EU, if we're storing sensitive data, we can't store it anywhere around the world. We have to store it in specific places. So make sure that your storage is A, as close to your metal as possible, and B, make sure that you're compliant with all of your local laws. Then we have the performance tier that we're going to be using. We have standard, we have premium. You pay more for premium. Standard is a little bit slower and you have less data throughput. Again, for this demo, standard's fine. We need to pick the kind of account that we want to use. We have 3 options here. We have storage v2, which is a general purpose v2 account. We have a storage account, which is a general purpose v1 account. This is for legacy purposes. Don't use this if you're not using it already. And finally, if you are using blob storage and you want an account tuned for that blob storage with a couple of extra features, then you can use a blob storage account. We're using tables and queues, so we're going to pick our general purpose. I'm going to skip the replication for a second and just go on to the access tier. We have cool and hot. We're accessing the data constantly, so we want hot. If you're not archiving data, hot's probably your best bet. And then the replication. We have 6 options here, and it gets to be a little bit of a tongue twister by the end, so I'm sorry if I get lost in how I pronounce these things. The cheapest option that you can have is locally redundant storage. and that is data storage which is redundant within your data center, or within a data center. The next option is zone redundant storage, and this is where your data is replicated to two data centers inside of one region. The next option is georedundant storage, and this is where georedundant storage, and this is where your data is replicated into a couple of data centers across two different regions. So if Azure has a problem in your region, a failover will happen and your users will still see, after a short delay, the data in the second region. The option under that is read access georedundant storage. You can see the names are starting to get a bit long, and this is where you can actually read the data in the second storage without the Azure failover. Then we have two new ones. I think they were available this year, if I remember correctly. Geozone redundant storage, and this is where your data is redundant across zones and regions. And finally, the most expensive is your read access geozone redundant storage. And that is where, the same as the previous one, you can access it without the Azure failover happening. After all of that, we want the cheapest, locally redundant storage. That's fine for what we're doing. So we're going to, again, review and create this, just to make sure I've not done anything daft again. Wait for Azure to do something, and then click create. And that's it. That's all the resources that we need for this part of the demo. Now I just want to check my pipelines and make sure that things have deployed. We have a build. We have a deploy. So if I go to my book club site, I can sign somebody up. So we have Amy Pond, and Amy Pond really wants to join our book club. Her email address is at the TARDIS. And Amy is really interested in 40s crime noir. So we're going to send this up to our API. We're going to go into my running demo. This is my pre-made environment that I was talking about. And at the bottom here, we have the storage account. Now, in the portal, under Preview, you have the Storage Explorer available to you. Previously, you needed to install an application for this. It is in Preview. It does sometimes have a couple of quirks, but for quick access to look at what data is in your storage account, I found it quite useful. So we're going to click on this, and we're going to check our table. And there is our book club sign up with Amy Pond in there. So that's it. In a few minutes, we've just written something that can send our data up to Azure and store it for us. Now this is awesome, but this method of doing it has a couple of issues. It's asynchronous. If everybody wants to sign up for our book club, and why wouldn't they? Amy Pond's just signed up. Then we can have an issue with scaling that web API. App services aren't the simplest things to scale within Azure. There's other much simpler options. On top of this, in the real world, we're not just going to be throwing this data into a table and then returning. We're going to be processing this data. And at any stage of processing this data, something might go wrong. And we don't want our customers to have to deal with this. Our customers, they just want to know that things work. And if we have a problem, it's our problem. We need to deal with it and just make sure our customer has a decent experience. So what we're going to do is decouple this. We're going to take the data from the customer, put it in a queue, and then we're going to read the data out of that queue and then put it into the table. Excuse me. So our app service is doing nothing except for just quickly throwing data into a queue and then returning to the customer. So we're going to go back to our code, and we're going to swap our queue code. We're going to swap our table code for queue code. So I'm going to create another quick folder here. If I can find the add button. And then we're just going to create another class for our queue access. For the queue, we only need one class. We don't need two. And again, I'm just going to get a little bit of a code snippet here just to copy in. Now we have some more red text here, and that's because to write to a queue, we need to install a different NuGet package. So we're going to install the Azure Storage queues. So let's go back into our NuGet package manager, and let's search for Azure Storage queues. Now we want to install the latest version of this. That becomes important in a minute. Again, we're just going to accept what we need to in order to use this, and then we can go back to our code. Now, from the outset, this looks relatively similar to the table access. We have our connection string, again, not in production, fine in a demo. And then we're passing in a queue name because, again, we want to reuse this code. We don't want to write it for every queue that we have. And how do we add something to a queue? Well, kind of similar steps as we have for a table, really. The first thing that we need to do is get a queue client. The second one that we need to do is not make an insert statement, but serialize the message that comes in. And you may notice this message is an object. If it serializes, you can throw it into a queue. And then we need to send this message to the queue. Now, I've got a result returned here. I'm not doing anything with this result. I just wanted to show you that data comes back from this, and you can do something with it if you need to. We've still got red code, and that's our get queue client. So what do we need to do to get a queue client from Azure? Another quick snippet. Again, reasonably similar to the table, really. The first thing that we need to do is get a queue service client from our Azure Storage account using that connection string. Then we need to get a queue client for the queue that we passed in our constructor. And just like a table, this may or may not exist. And if you use it when it doesn't exist, it is going to crash on you. So you're going to need to run again this create if not exist async. Now, when I added the NuGet package, I said make sure you've got the latest version, and this is really important. This create if not exist was only introduced in this API in version 12.3.0, which was released in March, I believe. Prior to that, you had to write this function yourself. So make sure you get the latest one. It means you have to do less work. And that's all that we need to do for the queue. So again, we're just going to do a quick check to make sure that that builds, make sure I've not done anything daft. And then we're going to do some cleanup inside of our controller. We don't need this adaption anymore, and we don't need the code for the table access. All that we need to do is await a new, not table access, but queue access, and then we're going to need to write this to a queue. 2 seconds, I just need to find my queue. Here we go. Now, the queue name that we're using, Book Club Signups, you'll notice that that's also all lowercase, unlike the table name, which had capitals in it. If you try and create a queue with capitals, it's going to crash on you. You've got to use lowercase, and again, it can make it difficult to read sometimes, I'm afraid. So we'll add this, and we'll add the request in there, and check that that builds. Now, there's one other thing that we actually need to do here, and that's back in here. I've got a JSON convert here, and you can just convert your objects to JSON and throw it at the queue, but we want to be using a function in a minute. And in order to read your queue out using a function, it's got to be base 64 encoded. In previous incarnations of this API, that was done for you, but that is now legacy, and in the new version, it's not available yet. So we're just going to add an extra little piece of code. So 2 seconds. Come on, mouse. So that is our to base 64 string, and we're going to be using that here, to base 64. And we're going to need to close that off. And I've done something wrong. To base 64, blah, 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 blah. Yeah. So we can push this up to Azure now. Change table for queue. We'll push that up, and we'll just check that that is building once it's gone. 2 seconds. Always when you're trying to do a live demo, things take much longer than when you're practicing. And our pipeline's building again. Now, that is all that we need to do in our API. Now we actually need to get this data and process it. For that, we're going to use an Azure function. So we are going to create an Azure function. So we'll just create a new project here. And we're going to use a project template for this. And that is our Azure function. You can also use a search box for it, but since things are taking a bit of time, I'm not going to do that today. We're going to give it a name. I need to make sure that this is actually created in a particular place, otherwise my Git repo is not going to pick it up. And then we need to pick the type of function that we want to create. Now you can pick an empty one, or you can pick a pre-scaffolded one, Cosmos DB triggers, HTTP triggers. You can also trigger a function via a web request. You don't actually have to build the API that I just built. There's pros and cons to this, which I'll get into later. And we have our queue trigger, which is the one that we're going to want. Every time we get data in our queue, our function will fire. We need to join that up to our storage account. The connection string setting is for when you're running multiple functions and you have different connection strings for each one. It's a way to keep them nicely organized. I'd recommend you use it, but I'm going to break my own recommendation for this demo. And then we need to give access to our queue. So that again is going to be our book club sign up. And apparently I copied the wrong thing. Come on, you can do it. There we go. So now our project's going to be scaffolded. The first thing that I'm going to do is just a little bit of cleanup to make it easier to use. And of course this takes much longer than I want it to, because why wouldn't it? Okay, so here we have our Azure function. Come on, do something. Thank you. This is a basic scaffolding thing. The first thing I'm going to do, I hate the name function one, so I'm going to just quickly change that. And that should hopefully, yes, Visual Studio is going to help me, maybe, please. Yes, there we go. And we also have this function name attribute. And I'm going to change this one to Book Club Signup Processor 2. And this is a name that you'll see inside the Azure portal. Don't put spaces in here. I did. It builds, it deploys, you see nothing, including errors, and you pull your hair out for an hour trying to find out what's gone wrong with it. Don't be me, don't put a space in. We're going to get rid of this connection object. This is that connection string that I was talking about when we were setting up the project. And the last thing that I'm going to do is we need to get our string, we need to deserialize it, but the function will do that for you. If you specify the type of object it's expecting and it can deserialize it for you, it will. And then we need to write to our table access again. And for that, I'm going to cheat, because rather than you watching me make the same objects twice, I'm just going to copy a bit of code from my signup API. So I want my table access and my models. And then I want to come into my processor. Paste this in here, and look at that. We have code magically available to us. So the first thing that I'm going to, well, I just need to do some slight cleanup here, because I need to fix my namespaces, because it's in a different class, of course. And then we can use that book club signup request directly in our function. There we go. And we're just going to call that request, because that's what the rest of my app expects. So now the Azure function will get the data from the queue, it will deserialize it for us, and we'll just have a nice object that we can use without having to do any work ourselves. For the table access, I also need to do that same namespace clearup, and I need to add the Nugget package, of course, because without that, things don't work. So let's just go and quickly install that. And quick search, and of course, yes. And just as before, we're just going to accept everything that it tells us to accept. So now we can go back into our signup entity, and we can say, move this to the right namespace. And we're going to do the same for our storage table access. And then finally, in our signup processor, we can quite literally just have exactly the same code that we had in our API. So paste that in here. We'll import the namespaces, and then we just need the adapt function to make sure that it works. Now we've still got a few red lines here from our other code. I said we can use exactly the same code. I was lying. Because the functions are static, we need to make this function static. And because we've got an await for our table access, we need to make the function asynchronous. Now, last check to make sure that it builds, make sure I've not done anything wrong again. Yay, look at that, it works. And push this up to Azure and get this deployed. Add function. So commit all and push. So now that this is being pushed up to my DevOps to be deployed, I need to show you how to create a function. Let's quickly do that now. That's been pushed. I just want to quickly check the pipeline's gone again. There it is. So if we go back to our resource groups and we go back to our lib demo, we can now see that we have the resources that were created before. We have our app service, our web app, and our storage account. And now we just want to add our function app to it, and then it will be complete. So we have our function app is in the often used section. It's easy to find. Check the subscription and the resource group, same every time. Give it a name, and you can possibly guess what's coming here. This has to be unique. Because again, this is how we use it. This is how we access it. So, function. Yay, no one's using that. We're going to be running on .NET Core. We're going to be running on 3.1. And again, we want to be running in West Europe. And then we need to have a look at the hosting for this. Now, one of the things that we need is a storage account. For the storage account, we're going to use the one that we just created. The region for your function is really important. It has to be in the same region as your storage account, or you can't pick it. You can update it after the fact to use different ones. I wouldn't recommend it. It makes everything really quite slow. If you have a function which isn't up and running yet, then the first request it gets, it has to build up the environment for you, and it gets the code from out of your storage account. If you're copying that from around the world, it means that your function takes that much longer to get set up. So keep it close. We're running on Windows, and we need to pick a plan type to run our function. We have three options: consumption, which is serverless, and this is where if your function isn't running, it gets spun up. After a while, it will time out and get turned down again, and this is why I don't use it for my API. That time it takes to spin up might give your customers a bit of a degraded experience. It's something you have to decide for yourself. You can do it, nothing wrong with that, but it needs to be a deliberate choice. Then we have a premium account, and this is where you have a pre-warmed instance ready to roll, even if your function's not running. And finally, you can actually just run this on an app service plan and just pay for the app service plan as normal. Again, we're going to go for the consumption. It works for us. We'll review and create this one. Wow, Azure's being really slow for me today. I'm sorry. So create that. That should initialize the deployment. And while that's deploying, I'm just going to check to see whether or not my Azure function has been picked up. And it has built. It is still deploying. So while that's deploying, I'm just going to sign somebody else up to my book club. Now, Amy has a husband, Rory. He's with Amy on the TARDIS, but Rory's not interested in 40s crime noir. Rory's interested in Roman history. So we're going to sign Rory up, and hopefully, if I'm quick enough, I can show you that Rory is actually in my queue. So I'm just going to try and quickly get through to my storage account. Come on, do something. Storage Explorer, and we have a queue, and here's Rory rating in the queue. And the fact that you can see this is why I didn't use an Azure HTTP function for my API, because this takes some time to get going. And even though it's only one user when your function is called, you don't want this kind of delay for your user. So that's deployed. Let's do a bit of a refresh. I'm kind of running out of time, so I hope this goes, because I really do want to see that this works. Come on, Azure, you can do this. Here we go. And now we have a queue which is empty. And with any luck, we have a book club sign up. And there's Rory with Amy signed up to our book club. So that's it for the demo. That's basically what we need to do just to create a very quick, simple, disconnected way of getting things from a static site and into Azure Storage. I have a little bit more presentation to go, but I'm probably going to skip an amount of it. There's only a couple of things that I want to really touch on. If my machine does it. 2 seconds. Here we go. So one of the questions that we had when we started our Hack Week was, what is this going to cost? Because our budgeting people had visions of us spending hundreds of thousands of euros a month going from our own data center and into the cloud. Well, for this experiment, I spent 6 cents. That is for writing this, that is for doing lots of practice, making a couple of mistakes. And I manage that because I use the Azure cost calculator, pricing calculator, I always forget the exact name, in order to figure out exactly what I needed to do in order to get this working. That's only me. For the bigger group, we had 6 teams working all throughout Azure. We did way more than just this simple one. We were using machine learning, we were using Azure Signal R services, and we had 2 weeks worth of Hack Week and setting up the Hack Week and organizing workshops. And we spent 25 euros. By making sure that you know what resources you're creating, you can create a whole lot of value without spending a whole lot of money. Sure, you've got to be careful. I have heard the horror stories of people pressing the wrong button and spending thousands without realizing it. But if you're careful, it's fine. Now, in order to get started yourself, if you are lucky enough to have a Visual Studio subscription from your company, then you get Azure Credit, depending on the level of your subscription, somewhere between 45 and 130 euros a month. Use it, because even if you make a mistake and spend all your money, which I've done a couple of times, that credit is also a spending limit, so you're not going to be in the nightmare situation. If you don't have that, you can take your own subscription, of course. That's how I ran this demonstration. But if you do that, please be very careful with what you're creating, because you don't want that on your own credit card. That's it for my talk. Thank you for your time. I say this was very much a fly-through. There's a bit.ly there, bit.ly command and query step 1. That is how I coded this demonstration. So if you want to try this for yourself, go there. And in the next couple of weeks, there's going to be a second one going through how I created the resources and get it deployed up to there. Thank you very much.
Yes, and thank you, Stacy.
And try not to trip over again.
Yes, of course.
Thank you, Stacy. This was really an excellent, I think, a complete walkthrough, actually, how you actually set up a whole solution and discover all the available options in the Azure portal. It was so detailed.
Yes, thank you.
I loved it. And there were really lots of little gems in there, like storage account name limitations and stuff like that. I can imagine it did cost you probably quite some time to figure everything out. Or
yeah, but this one cost an amount of time to get set up.
Yeah.
I think the big one for me was really the function name attribute.
Right.
Because really, I got it working once. It's like, yeah, okay, this is fine. This is what I want. So I'm going to delete it now, and I'm going to make sure I can recreate it from my notes.
Yeah.
Nothing worked.
Yeah.
Nothing worked. My function's not picking it up, and it's really, you're staring at it, and everything's compiling, and you're getting no errors anywhere, and yet it's not running. And that was literally an hour of pulling my hair out, screaming, and
that must be so frustrating.
Yes,
yeah, exactly.
absolutely.
I do know the feeling, definitely. Yeah. So, but do you think if things are like that are still missing from documentation or examples or stuff like that?
I think it's probably, I was possibly too lazy. I'm going to own that one. But I think what is a little bit confusing is the fact that different resources have different conventions and different requirements.
Yeah. Yes.
But yeah, that one definitely, that was just pure my own stupidity. I think that one was really... The good thing about it is I actually learned a lot because of that. Because the first time I went through it, everything worked. Yeah. And the second time it didn't work, and that is where you learn stuff, because it's Stack Overflow, it's the Microsoft documentation, and it's trying to find what you've done wrong. Yeah, you should really embrace the failure part more and don't be too scared of it. It's definitely at the time it doesn't feel like it, but after the fact you can really look back on it and go, yeah, that was... Yeah. If that had never have happened, I wouldn't be able to say that in this talk, because it wouldn't have clicked for me. Exactly, yeah. And how would you advise teams new to this, how to approach this? What I would advise, if they have that Visual Studio subscription, is really play. Because you can really do what you like there, and it doesn't cost anything if you make a mistake. It's only frustrating because in the middle of the night you get an email saying, hey, you're nearly at your monthly limit, and the next day you can't access your account. But that aside, you can really play and start to do things. And the second one is really pick a real world example for you. What do you want to build? And then do some research on the Microsoft Docs. There's plenty of tutorials on YouTube. If you're lucky enough, Pluralsight is fantastic. But make sure you're doing something real world. Because I think the biggest issue that I see a lot of people having is, cool, I've got this hello world, but exactly, that doesn't really scale well to something real indeed. Keep it real, close to yourself, that you understand the domain, and then you can really focus on that's why I was really happy with this hack week that we had. We made sure that we had the product owners on board with us too, because it was also trying to get people into a more DevOps mindset instead of a silo mindset. So it was also trying to help that with the product owners too. It's like, okay, we're not going to tell you what we're doing, but we need you. And then it was like, okay, so we have a week to produce something. What do you think would be really cool that we can quickly produce inside of a week? And all the teams came up with so many different ideas. Oh, great. I say machine learning so that we could pick up what people thought of the company by reading tweets. Oh, wow. That was cool. People using the Azure Signal R service so that we could actually do updates with users on the fly instead of having to wait for them to come to us. And it was all stuff which, if you'd left it to the developers, I'm not sure that we would have got all of it. There was a lot of stuff that came from the developers, but an awful lot that came from the business too. And it's where that joins, that's where you really learn the power of what you're doing.
Definitely agree with that. Cool. I really enjoyed it. Thanks a lot, especially the TARDIS references. Thank you.
Yes, you got the TARDIS
Yes,
references.
thank you.
Yeah. Big Hoovian.
So no, please keep it up. I want to see more tutorials of this. So please start your own YouTube channel. I'm watching.
Awesome, thank you.
Yes, or a podcast or something. You need to get this out there.
I really want to start a podcast, but it's one of those things where it's like finding the time and getting over the imposter syndrome in order to get going.
You're fine. You're fine. We had a lot of fun, and it was so interesting. But we also, you probably couldn't hear it at home, but we laughed so much.
Yeah, it's the way you bring it. It's really nice. Yes, I like it. Yeah.
And sometimes like the little frustrations you have with some things or had with some things, they just tiny weeny little bit. Exactly. You notice them. Yes.
Awesome. Thank you.
So thank you very much. Today we've been joined by our interpreters. They will stay for another hour, but we got great feedback, and I just want to thank them. So a big thank you to Oliver, Maya, and Lair. Yes, we know you enjoyed it. We did too. There's some things, of course, I need to upskill on. Words like rabbit, duck, unicorn, cat. Okay, and what? Badger. Oh, that's difficult. Okay, the badger is too. I don't get that one. I have to really practice that one. So amazing. So we are going to break for a little while. Our next session will be Daniel Paulus. I see him already setting up his stuff. So that's good. He will have a session around AKS and more specifically Azure policy with Gatekeeper. Let us know if you enjoyed today's session on Twitter, for instance, using hashtag VACD, or give a shout out in the chat. We're really curious on what you're thinking. So see you after the break.